Hello, so today we're going to look at matrices. A bit of an introduction to matrices. Okay, so let's have a look at what they're asking us. So for the following system of equations, write an augmented matrix for the system of equations. Produce the matrix in A. So I'm assuming this is reduced echelon form. Determine the solution, if any, to the system of equations. And I think that's it. Okay, so let's pick a color and let's start the problem. So for the following system of equations, we have 3 equations and 3 unknowns, right? And we're asked to write an augmented matrix for the system. So what's an augmented matrix? An augmented matrix, well, what's a matrix? A matrix is a box of numbers. And for a system of equation, this box of numbers is made up of the coefficients in front of the variables. An augmented matrix, so let's start with that. Let's start with making a box of numbers for the coefficients of all our variables. So we have 3 equations, so we're going to have 3 rows in our box of numbers. We have 3 variables, so we're going to have, at least to start, 3 columns. So each column represents a variable, each row represents an equation. So let's take the first column to represent the first variable x. So in that first column, we're going to put all the coefficients of x for each of our equations. So we have 2, 1, and -1. The second column is going to represent the second variable, so y, and we're going to look at all the coefficients of y for all 3 equations. So in the first equation, it's -1, second equation, -1, third equation, -1 as well. So the coefficient of y for all 3 equations is the same, -1. So why don't we just put a little x at the top, y, and the third column is going to represent our z variable. Let's look at the coefficients of z. First equation is -1, second equation 4, and third equation there's no z, so the coefficient is 0. So this small little matrix here, or this box of numbers, represents the coefficients of our variables, or is called the coefficient matrix. Now we're asked for an augmented matrix. So if we look at our equal sign, all the numbers on the right-hand side of the equal sign, we're going to put those numbers in the in the fourth column, the last column of our matrix. So we're going to put our -2, our -1, and 13. So now we have an augmented matrix for a linear system. So this is the augmented matrix. Good. That takes care of part A. So now we're asked to reduce the matrix in A and then determine any solutions, the solutions, if any. Okay, so let's do this. So that's part A. Now part B, we're going to row reduce. Okay, so let's start with, sometimes little strategies required. So why don't we take that second row and add it to the third? So we'll do row 3 plus row 2, 0, -2, 4, and 12, 1, negative. And we're just going to keep row 2 exactly the same. And then we're going to add -2 row 2 to row 1. So we're going to get 0 in the first component, -2 times -1 is 2, plus our -1, -8 plus -1, -9, 2 plus our -2 is 0. I believe that's correct. Good. All right. So we're getting there. Let's move over a little bit more, do a bit more work. Okay, so now why don't we use this one and try and eliminate all the ones or all the values in that second column. So we're going to leave that first row as is, and then we're going to add row 1 to row 2. So I'm trying to think where we can write that. row 2 plus row 1. So we have 1, 0, -5, -1. We're going to add 2 times row 1 to row 3. So row 3 plus 2 row 1. And what do we get? We get 0, 0. -18 plus 4 is -14. 12. Okay, that's looking good. All right. Why don't we continue? It's a little smaller. Let's continue down here. Okay, so let's see if we can, factor something out there. So the first thing I would do is I'd interchange row 1 and row 2. Row 1, interchange row 1 and row 2. I just want to get that one in the top left-hand corner in place. Okay, good. All right, and now in the third row, why don't we divide? What should we divide by? Should we divide by -14? See what happens. All right. 0, 0, 1, and 12 over -14. We have a common factor of 2, so it's actually 6 over -7. 6 over -7. Okay, that looks good. All right, so now what we're going to do is we're going to take this 1 and try and eliminate the -9, the -5. Let's see if we can do that easily. Okay, scroll over here. Okay. So we're going to add 5 times row 3 to row 1. So row 1 plus 5 times row 3. 0, 0, 0. 5 times row 3. We got -1 plus 30 over -7. I think that's right. Second row, we're going to add 9 times row 3. So row 2 plus 9 row 3. 0, 1, 0. All right, and then we have 9 times this. So 9 times 6 is 54 over -7. And 0, 0, 1, 6. -7. Okay. All right, that's not so bad. Okay, good. So it looks like we're finished row reducing. So let's go back to part B, see what the question, reduce the matrix in A. So we've done that. Determine the solution, if any, to the system of equations. Well, let's look at our final matrix here. Whoops. Okay, so we row reduce. So this augmented matrix, this row reduced matrix, represents a system of equations, and that system of equations is equivalent to the original system of equations. So let's write out the system of equations represented by this final row reduced matrix. So part C, we have, remember, the first column represents x, so we have x, and then the last column represents what's on the right hand side of the equal sign. So we have x equals -1 plus 30 over -7. Let's clean this up, put everything over a common denominator. So we're going to multiply by -7, and we get 7 plus 30 over -7. We get 37 over -7 for x. Second row, second column represents the y variable. In the second row, we have the equation y equals 54 over -7. Third row represents a third equation. Third column represents variable z. Z equals 6 over -7. Good. So it looks like this final linear system, or system of equations that's equivalent to the original, is our solution. So what is our solution? Therefore, our solution is a point and unique is given by, let's put that, given by 37 over -7, 54 over -7, and 6 over -7. Good. So I believe that brings us to the end of our session. If you have any questions, feel free to send us an email at info@raisemymarks.com or give us a call. You can send us an email or give us a call day or evening, and we'll be happy to help you however we can. Thank you for watching. We look forward to seeing you soon.